3-3 angles of polygon, still state-centered 8G5. Today we're going to talk about a polygon. A polygon is a closed plane figure made up of 3 or more line segments that intersect at their endpoints. So we're talking about that polygon, triangle. That one, notice, drawn quickly, does not have lines that end only at their endpoints. It's open. We're not going to see a lot of that, but we're referring to just shapes that are closed. Anything that's made up of line segments. Straight lines, however they are, those are polygons. My favorite one, that's not a polygon, the good old tombstone, or this guy. It is not a polygon because it has not line segments. That's the key phrase. It must be straight lines, it must be closed, and they must meet at their endpoints and not make any X's in between. When we talk about them, there's 2 types. So if it tells you to explain or to name or classify the polygon, you've got 2 options. They're convex and concave. I usually just remember concave, like it caves in, and that's how I know that one, and thus if it's not concave, I know it's convex. But explaining convex, every line segment connecting any 2 vertices lies entirely inside the polygon. So if I draw a polygon, this one happens to be an octagon. If I were to connect any of the 2 vertices, this one and that one, notice that line lies completely, entirely on the inside. If I connected 2 different ones, if I connected these 2 completely on the inside, even though these vertices are already connected, that's why we're going to kind of skip those. I connect those ones inside, that's inside. Every time we look at it, all the ones you connect, the line always lies on the inside. That's convex. Myself, that never always stood to me. I couldn't make that click or connect, but concave, that's something that I could understand because this word cave, something caved in. So when we're talking about a polygon, it just needs to be made up of straight sides. So a lovely hexagon down there. Now that one's concave. Does it look like it's jutting in? It's caved in on itself? Yes, that's why it's concaved. Otherwise, what you'll note is that when we talk about connecting it, we could connect these 2 and they lie on the inside, but at least one of them, when you connect 2 points, 2 corners, it lies on the outside of the polygon. So that's what you're going to see there when we focus on the outside. That's concave. It caves in on itself. That's how it always stood out to me. Now this word regular is so important, I want you to just circle it up like crazy. The word regular, they're just going to drop that in a problem, and you need to know what that means. Otherwise, you're going to look at it and go, how do I know what that is? Regular means everything's the same. We'll put it down, all the same. All the sides are the same. All the angles are the same. It is regular. All the things are the same or congruent. Huge. Cannot emphasize that enough here today on your assessments, even on state assessments or at math counts, math tracks, those things. They'll just put the word regular in there, and if you don't remember what that means, then you don't have enough information to solve the problem because that word regular is key and vital. Now this is a formula we'll be using a lot today. So highlight it, box it, put happy faces around. If you're in class, I'd put smiley faces around it or stars because it's a formula, so you need to write it on in because that's worth a point, as well as it's going to help us answer this. The sum, S, of all the interior angles, all the interior measures, angle measures of a polygon with end sides, whether it's 12, 15, whatever it might be, 4, 6, with end sides is this formula to help us find that out. Find the sum of the interior angles of the polygons. When we do that, it's very important that we count carefully, please, because it's your notes. I want to write down a 1, a 2, a 3, a 4, a 5, and a 6. You may not know the sum of all 6 angles in this shape, which since it's 6, it's technically a hexagon. Not going to go over that today, but I'm going to write that on in. There's a reminder for us. When it says find the sum up here, find the sum, that's going to have to cue and remind us of a formula we need to write on in. So, yep, you already got the smiley faces. It's right there. You're going to write it in just like you see it. S. You're going to write it in just like you see it. S equals n minus 2 in parentheses. And then that 180 degrees, if you need to put a time sign there to remember that, please do. And let's rewrite it. S equals, what was the n, the number of sides we saw in our polygon here? 6 minus 2 times 180. Now, follow your teacher's instructions. In class, I usually say that this is enough work for me. Type it into your calculator and get the answer. Otherwise, what you're looking at is you can follow along. You can simplify down. That simplifies down to 4, and then you can take 4 times 180 to get your answer. So all the interior angles sum up to 720 degrees. As a reminder, in Mr. Walls' class, whether it's an assignment or test, formula is a point. This work required is a point, answer, a label, and a point for trying. 5-point question on a quiz assessment as you're looking at those. Now, I didn't say to name, classify the polygon, or describe it, but we named it as a hexagon, and we could also say that this one is, if we needed to, a convex polygon because it's not caved in on itself. If we drew lines from vertices, all the lines we draw would all be lying on the interior. So as you're looking at those, that's how, again, you can tell that it's convex. Another thing to do, find the value of x. Well, Mr. Walls, what do I know? How do I know what they add up to? Great question. You can either count all the angles, which is helpful, or you can count the sides. Be very careful as you count, because if you mess up your counting, it's with a small tear in my eye that I'll take the red pen out and count it wrong, even though you've done all the math right. If you said 8 or 6 on here, you're close. But again, sides, there are 7. 1, 2, 3, including the x, 4, 5, 6, 7 angles. So when you say, but Mr. Walls, how do we start this? How do I start finding the value of x? Well, you're right. How do you start that? Well, that should make you think, there must be a formula, and you are correct. We'll be using this and writing it down almost every problem, starting here. The sum, again, n, how many numbers, how many sides were there, how many angles were there? You got that. That's enough work, or if you wanted to simplify it down and say that's 5, you can do that and then type it into your calculator, handy dandy calculators, away you go. Awesome. So the sum of all the angles in a convex heptagon, because it's 7 sides, so that's a heptagon, are 900 degrees. That's not what it asked. It said to find the value of x. So if you know everything adds up to 900 degrees, then let's add it all up to 900 degrees. When we do that, that's where you're going to start. So whatever you did here with this formula right here, this is so important because that's now your starting mark. 900 equals, and now add up each one of those angles that they gave you. I'm going to start with the 112. And I'm going to go around the other way. So I've done 112. I'm going to write in 160 plus 121 plus 130. Yes, you're going to have to write that on in on your notes. Yes, you're going to have to write that on in on your assignment. And then plus x. Again, when you count them up, 1, 2, 3, 4, 5, 6, 7 angles for a heptagon. Once you have done that, you're right. They're all still going to add up to 900 degrees. Now you need to add up all those ones carefully. Type it into your calculator twice, maybe even 3 times to make sure, because if you accidentally add one of those wrong, so the tear in my eye, the red pen comes out, and I mark it wrong. So those add up to 776 in class. I'd make sure that we got that 2 or 3 different times from a couple of different people. Now that we have that, yes, well, don't I just subtract them all? Yes, you do, but sometimes there are going to be multiple steps in this. More than one x, they'll have more like terms, so I want you to do the work like this, so you got that muscle memory, combining it, and then yes, you're right. you're going to add a negative 776, or you're just going to subtract 776 from both sides, so that way you can find out the value of x is 124 degrees. Again, Mr. Walls' class, formula, work, 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 answer, label, point for trying. This is a 1, 2, 3, 4, 5, 6, 7, 6, maybe 7, maybe an 8-point problem on assessment. So yes, show the formula. Why? 1, I told you so. 2, it's going to help you get the answer, the right spot to start. 3, it's worth a point. And 4, by writing it in, you're going to remember it and be able to write it in easier. A cloud system is approximately in the shape of a regular 12-sided polygon. Find the measure of each interior angle. All right. Well, if it's 12-sided, we're going to start right away. You're thinking to yourself, oh, yep. I will put a smile on your face because you are absolutely correct. Here it comes again. Writing on in that formula, n minus 2. And 180 again, sum of all the interior angles. That n comes from the number of sides, 12, minus 2, 180. Again, that's enough work there that you can just type your calculator, or you type in here, show the work 10, and oh, hey, I can do that mentally. Awesome. Mr. Walls, I still need a calculator. That's fine. 1,800 degrees. Awesome, but don't put a box on it. That's not your final answer. Now it says find the measure of each interior angle. But how do I do that, Mr. Walls? I don't see them. I can't tell anything about them. Aha. That's again where that word, put a bubble cloud around it, highlight it. This word regular. In class we'd have a discussion about it, but for video notes, keeping it short, that means all 12 sides are the same. That means all 12 angles are exactly the same. If all 12 angles are exactly the same and they need to add up to 1,800, then all you're going to do is you're going to take that 1,800 and you're going to divide it by the total number of sides we had, the total number of angles that there were. That way you can get it. And for the most part, with us, they're going to come out to nice answers, maybe a small decimal with tenths or hundredths, 1 or 2 decimal places. If you get a bit of really long repeating decimal or something, we've probably done something wrong one spot, mental math or a quick calculator error. But each angle then in that polygon is going to be 150 degrees. Again, we got there from the start where we used the formula. And then once we knew that we had 1,800 degrees in the entire thing, you're going to go back, and since we started with 12 sides, that's where this 12 came from dividing, and off we go. Now, here's the big thing. We're talking about all different types of angles, no matter how many. So if you need to make that note, all exterior angles, whether it's 3 or 33, they're all exterior angles will always add up to 360 degrees. All of them, all exteriors will always be 360 degrees. Notice though it must be in a convex polygon. So if it's concave, we can't do this. But you see we got W, X, Y, and Z, just 4 random angles. They're going to add up to 360 degrees. Awesome. So let's take a look at that. Find the measure of the exterior angles. How am I supposed to do that, Mr. Walls? Oh, do I use that formula? No. Since, look at it. Here's the big thing. Exterior angles. It's plural. Since we're talking about all of the outside angles, again, all of them are going to add up to 360 degrees. So from there then, go ahead and add them all up, meaning the 91 and the 62 and the 121. And then don't forget about the X. Mr. Walls, can't we just take 360 and subtract the other 3 angles? You're absolutely right. But as you can see from the behind the screen I have hidden here, there's another example with more than one term. So this way, by doing the work you see here, you're going to get that muscle memory. You'll remember how to do these and have a better chance, maybe at not so forgetting or panicking about what to do. So now you're going to add up all those like terms, 91, 62, and 121. They add up to 274. And then solve. Yep, you're just going to solve by adding a negative 274, or of course you can subtract 274 as well. Both work. Calculator mental math approved. Careful, it's not 106, that's not 96. It's 86. Quick mental math spots to make quick mistakes, so be very careful. When again, look at the answer to the question. If it said find the value of x, 86. Since it said find the measure, we're going to want a label on that 86, so make sure it's 86 degrees. That's our answer. Now over here, again, we're talking about all exterior angles. They're all always going to add up to 360 degrees. Now add them all up. You pick any one you want to. I'm going to start with the x plus 10. That one's on the outside. Plus x. You don't need to put the x plus 10 in parentheses. They're putting it there because of that label degrees. And then we have to remind ourselves, what does this guy here mean? That means it's a right angle, it's 90 degrees. Please remind yourself, if this inside is 90 degrees, then because these guys, when you put them together, make a straight angle, a supplementary angle makes 180 degrees, that's why it's going to be 90 on the outside. Don't forget that right angle means 90 degrees. From there, add up your like terms. This is why I wanted you to show the work, because now, instead of just subtracting things, you have 360 equals 2x plus 100. Oh no, Mr. Balls, a two-step problem. Nah, you've got it. Two-step equation. We want to focus on getting 2x all by itself, so that means we're going to start with the 100. We're going to get rid of the 100 by subtracting it or adding a negative 100 to both sides to give you 260 equals 2x. And now that you have done that, you can then divide both sides by 2. Mental math calculator approved. That tells you x is 130 degrees. Perfect, but be very careful on this one. If you box that up, we'd have a discussion in class why that's wrong. But for here, it's wrong because it says don't find the value of x. It said find the measure of each exterior angle. So going back up here then, we know that this one is 90 degrees. Great. So you can write that down, 90 degrees. And now what about this guy? That guy was x. Well, what do we find x to be? Well, that's down here. Yay! 130 degrees. And then don't forget about this last guy here. X plus 10. So going back down here, here's our x. 130 plus 10 gives us 140 degrees. Be very careful. Read instructions. Quiz or assessments will sneak that on in. There are 2 points each. One for the 90, one for the labeled degrees, one for the 330, one for the degrees, one for the 140, one for the degree symbol. So there's 6 points right here in this answer. So when we forget that on a quiz or assessment, very quick way to lose some points. Also something quick to get back on test corrections. Today, I can find the sum of the interior angles of a polygon. That should make you smile a little bit. Maybe not, but you've got that formula. So then notice here it is all exterior angles add up to 360. And then knowing that, you'll be able to find measures of either interior or exterior angles of a polygon. And please remember, in class I'd say it one more time, so I'll say it here. The word regular means all the sides and all the angles are the same.